Properties of exponents. When in doubt, write it out. Expand it. Instead of having the problem 3x to the third times 2x squared times 4xy times 2y to the third. I don't know how to do that problem. So when in doubt, write it out. When in doubt, write it out. So instead of writing 3x to the third, I'm going to write down 3xxx. That's 3x to the third. What would you put instead of 2x squared? Who knows? What can you put, Isaac? 2xx. Good. What would you put instead of 4xy? Is there any way to expand that? No, we just write 4xy. How about 2y to the third? What could you put? Y. When in doubt, write it out. If you expand it, then I can visually see like terms. What's going to go together? What can I put? What can I combine? What can I rewrite in a simpler form? Noah, give me one thing. The x's. How many x's do you see? 1, 2, 3, 4, 5, 6. X to the 6th. What else can go together? What can go? The y's. 1, 2, 3, 4. Anything else? The whole numbers, my coefficients, right? The numbers in front. 2 times, or 3, that's a 3, times 2 is 6. Times 4, 24. Times 2, and there's my answer. That's it. When in doubt, you can write it out. However, do you think that's going to get boring and tiresome? Too much work?
Really? Because you can just add them in your head.
You can. But there's a rule. There's a shortcut. When the powers have the same base. When the powers have the same base. What's the base? The whole number. The number touching that exponent, right? So like x, y. I've got coefficients of numbers. 3, 2, 4, 2. When powers have the same base, when the bottom number, the big number in the power, the bottom one, is the same. When powers have the same base, what can you do to the exponents? What's a shortcut? How do we get 6 over here? What do we do? When powers have the same base, so x to the third, x squared, and x. When those three have the same base, or y and y to the third, those have the same base. Derek, what can you do? Add the exponents. When powers have the same base, Add the exponents. Well, if I look, let's see. X to the third, x squared, x. 3 plus 2 is plus 0, plus 1. 5 plus 1 is 6. It worked. Let's see the 4. What's this exponent? 1. Plus 3 is 4. If the powers have the same base, add the exponents. What do you do to the coefficients? What do you do to the big numbers? Multiply the coefficients. You could use that shortcut. Could you, when in doubt, write it out every single time?
Sure.
Yes. Does it work? Yes. Is this way a little bit faster sometimes? You bet. But they will both give you the same answer. So I want you to try one on your own. See if you can do it. Try that problem. 4a to the third b squared times 3a to the fourth b to the third. What could go together? Who can tell me like terms? What can I combine? I could expand it. When in doubt, write it out. But let's use the rule. Noah, give me one thing that can go together. A to the third and a to the fourth gives me what? What do you do with those exponents? Add them. 3 plus 4 is a to the seventh. What else can go together? Isaac? The b's. B squared goes with b to the third. Add your exponents. 2 plus 3 is 5. Anything else? 4 times 3. Multiply the coefficients. 4 times 3 is? There's your answer. All right, let's try this type of problem. Three x to the fourth to the third. 3x to the fourth to the third. When in doubt, what could you do? Write it out. Instead of 3x to the fourth to the third, I'm going to put Does that work? Is that a true statement? Are these equal? Are they the same? This outside exponent of 3 means the parentheses happened 3 times. 1, 2, 3. Can we use the rule that we just learned? When powers have the same base, add the exponents. What's the base here? X. What's the base here? What's the base here? So can you add the exponents? Yeah. X to the fourth, x to the fourth, x to the fourth. They're the same base. X, x, and x. 4 plus 4 is 8. plus 4 is 12. And what do we do with our coefficients? Multiply. 3 times 3 is 9 times 3 is... There's your answer. I wonder if there's a faster way. Look at the beginning problem. Look at the answer. See if there's something that jumps out at you. Look at the beginning problem. Look at the answer. See if there's anything that jumps out. Jacob, what do you see? Perfect. Jacob saw 4 times 3 is 12. But how did I get that 27? Stephanie, what'd I do? Perfect. That 3 on the outside, because it's in parentheses, I can distribute it to everything inside. I'm distributing the 3 to the x, and I'm distributing the 3 to the coefficient 3. When powers have powers, there are two exponents touching. When powers have powers. When powers have powers, two exponents touch. Stephanie told us to distribute. That's what those parentheses say. Distribute the exponent. That 3 on the outside, that exponent of 3, belongs to the 3 coefficient, and it belongs to the x. Distribute the exponent, and then I forgot who. What'd you say, Jacob? What do you do with the 3 and 4? Multiply the exponents. 4 times 3 is 12. And 3 to the third power, 3 times 3 times 3 is 27. Don't forget the coefficient gets the exponent 2. Don't forget that. That's the most common thing people forget. They're going along and they multiply, but they forget to distribute before they multiply. We're almost done. Is any of this coming back to you? A little bit of memories from pre-algebra? All right, let's try this problem. This is a division problem. It's new and different. Division. Do we have any rules about division written down? Not yet. So when in doubt, write it out. How do you write x to the 6th out? Good. X, 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 X. How do you write out y to the fourth? Y. How do you write out z to the third? Z. That's the numerator. Let's do the denominator. Who can expand the denominator, the whole thing? Tell me the entire whole denominator. Zach B. Good, and I'm going to group mine. X's under X's. Oops. Y. Z. X squared, XX. Y squared, YY. Z. Think I can do anything here? Kayla, what happens when you take X divided by X? Yeah, it disappears. It cancels out. They're inverses. X divided by X. Does that happen anywhere else? Where else? Another X and X, right? Anything else cancel out? This set of Y's cancel out. And these Y's cancel out. Anything else? And a pair of Z's cancel out. Anything else cancel out? All right, so what's my answer? One, two, three, four. X to the fourth. 1, 2, y squared. 1, 2, z squared. I did it. When in doubt, write it out. It works every time. The answer is x to the fourth, y squared, z squared. However, this seems like a lot of work. Is there a shortcut? Yeah, there is. Look at the problem. Look at the answer. Look at the problem. Look at the answer. Miles, what do you think? Let's see if he's right. X to the 6th, x squared. 6 minus 2 is 4. 4 minus 2 is 2. 3 minus 1 is perfect. When powers have the same base, you can only do it to the ones that have the same base. When powers have the same base, what do you do, Miles? Subtract the exponents. What if they had coefficients? What if this problem was 4 over 6? What would you do to 4 over 6? 4 divided by 6. Does that work? Does 4 divided by 6 work? Can you simplify 4 over 6? What is 4 over 6 simplified? 2 over 3, that would be our exponent, or our coefficient. 2 over 3 would be our coefficient. What if it was 14 over, what do I want to make this? 7. What if it was 14 over 7? I could divide 14 divided by 7, couldn't I? So maybe you simplify or you divide the coefficients. If there are coefficients, you need to simplify them if they simplify. But if they divide into whole numbers, go for it. Two more pieces of information before you start your homework. Are you ready? I'm telling you right now that all of these, 10 to the 0 power, 9 to the power of 0, 45 to the power of 0, y to the power of 0, I'm telling you, every single one of those all have the same answer. Jonathan, what are they? 1. Anything to the power of 0 automatically becomes 1. Are you ready? Here's your trick question. What is the answer?
X.
Ooh, who said X? Brayden? You're right. Why?
Because 0 is over y.
0 only touches the Y. Does it touch the X? No. This problem is really X times 1, which is X. Next. You cannot have negative exponents. It's a rule. The law. There it is. So Miles says why? How come? What's going on? Yes, you can. Miles says, Mrs. Long, if you have x to the 6th divided by x to the, or x to the 4th divided by x to the 6th, it's division, so what are you going to do? What's 4 minus 6? X to the negative 2. Miles says, yeah, you two can.
No, I'm asking why.
But you did. I just proved that you can have a negative exponent. Didn't I?
Yeah?
But I just said you can't.
So what do you do?
When in doubt, what?
Write it.
Write it out. Instead of x to the 4th, what would you write? 1, 2, 3, 4. 4 x's. Over. Instead of x to the 6th, what would you write? What else can I do? Cancel out. So these cancel out. These cancel out. These cancel out. And these cancel out. What does x to the negative 2 mean? Because over here I have x squared. I have 2 x's. But where are they? Where are they? In the denominator. If you have a negative exponent, they belong in the denominator. So what should I fill in and hold this place? Not a 0. If I put a 0, it disappears. A 1. So what's the rule? You cannot have negative exponents. If you get a negative exponent, what should you do?
Put it on the denominator.
If you get a negative exponent, move it to the denominator. What if I do the problem and I end up with a negative exponent already in the denominator? Where should I move it? To the numerator.